go for discussing about the digital signature standard algorithm. In the digital signature uses an algorithm that is designed to provide only the digital signature functions. Only the digital signature functions. Now here we are considering the message and we are inputting to the hash function. Then we go for sign function, and here user A or A and a global public key. Global public key and one more key, that is session key. Session key, right? And see, this is inputting to the concatenation. So sometimes it is transmitting straight away from message to concatenation. Then, so it is the variables or and else. So here the message is hash function, inputting to the hash function, and here we have the verify. This is inputting to this, this is inputting to this, and one more input, that is from hash function to inputting to the verify function, and here it is verified by the public key of global public key and public key of the second part. Public key of the second part, right? Global public key. Right? So it is verified, and then we go for comparison. Right? So here, this is the representation for digital signature standard, and when we are considering the message, and so this is the direction of flow. So if the message is transmitting towards this direction, so straight away it is inputting to the concatenation function. Now it is sometimes it is transmitting towards this direction. That time the message is inputting to the hash function. So the message is converted from plain message to hashed message, and now the hashed message is inputting to the sign function. Here sign is instead of encryption, we can use sign. So the hashed message is signed by the private key of user A and global public key, KUG, global public key, and one more key we are inputting, that is session key. Right? So now the signed message is inputting to the concatenation function. So from here, this is come to here, the signed message, and here we are taking two parameters R and S, and these two are inputting to the verify function. So instead of encryption, here we use sign function. Instead of decryption, we can use the verify function. So that signed message is verified by the public key of user A and the global public key here, and then go for comparison. Right? Come to the comparison. Suppose it is transmitting towards this direction. Here we have only plain message. That time it is inputting to the hash function. So come to the verify function, and here we generate the hash message. Okay, comparison. This is the representation for digital signature standard approach. This a hash function. The hash code is provided as input to a signature function along with a random number k. So along with the random number k, along with the random number k, it is for this particular signature, right? The signature function also depends on the sender's private key. That is, signature function also depends on the sender's private key, k or sender's private key, and a set of parameters known to group of communication principles, right? So here we can consider this set to constitute a global public key, that is called KUG, global public key, constitute, right? And so the result is a signature consisting of two components labeled R and S. Two components labeled R and S. Now you go for calculating the RSA algorithm, right? So before that, the verification function also depends on the global public key as well as the sender's public key, which is paired with the sender's private key, right? So now you go for calculating the RSA algorithm. We consider the prime number, let P be a prime number, let P be a prime number, the P lies between 2 power n minus 1 is less than P, less than 2 power n. So P is a prime number, the prime number lies between the 2 power n minus 1 less than P less than n. So where n is the length of the prime number, right? And let Q be another prime number. Let Q be another prime number such that Q be another prime number such that P minus 1 mod Q equal to 0. P minus 1 mod Q equal to 0, right? So calculate the G. Calculate G. So G equal to H power P minus 1 by Q mod P. Mod P. Right? Where the H lies between 1 and P minus 1. Right. So where the H lies between 1 and P minus 1. 1 is less than H, less than P minus 1. Right. So now you go for choose the random integer x such that x between the 0 and P. So we can choose the random integer. Choose the random integer x, where x lies between 0 and P. Lies between 0 and P. Then calculate y. Calculate y. See here y equal to g power x mod p. G power x mod p. So y equal to g power x mod p. Y is a public key, right? So now here y is a public key, therefore e suffix a equal to y. Earlier, so when we discussed about the public key cryptography algorithm, public key cryptography, so we can use two keys, private and public keys. The private keys are referred by D and the public keys referred by Y, right? Next, choose the random integer k. Choose the random integer k. K lies between 0 and q. K lies between 0 and q. 0 is less than k, less than q. Right? Now, so go for the algorithm. First, the sign algorithm. the signature algorithm. So this is the first step. R equal to g power x mod p, g power x mod p whole mod q. R equal to g power x mod p whole mod q. And another parameter, that is s equal to k inverse h of m plus x into r plus x into r whole mod p. Sorry. So s equal to k inverse hash message, the summation of hash message and product of x into r, x and r mod q. This is signature algorithm. We consider two parameters r and s. R equal to this much and s equal to this much. So later we will calculate the values in numerical, right? And verify algorithm. So here t equal to u hash message into m into s inverse whole mod q, and u equal to r into s inverse mod q, and v equal to g power p and p into y power u mod p whole mod q. So we will getting v equal to r. So it is x. Then algorithm is proved, right? So this is here two modules. One is signature algorithm and another one is verifying algorithm. In signature algorithm, we take two parameters r and s. R equal to g power x mod p mod q and s equal to k inverse into hash message plus x into r whole mod q. So verifying algorithm t, u and v. In verifying algorithm you get three parameters t, u and v. So t equal to something, u equal to something and v equal to something. When we calculate the values, we will get v equal to r, then it is accepted. Right? So we will take some numerical example like so in we consider the hash message is something and the h equal to something and the prime number p equal to something and the integer k equal to something, right? So here we consider the hash message 3 and the h. So we will consider 2 and p equal to 7 and k equal to 2. Right? So we go for calculate the values now. First we calculate the value for g. G equal to over calculate the value of g. G equal to h power p minus 1 by q mod p. So we can substitute the values where h equal to 2 and the prime number p 7 minus 1 over by q. What is the value of q? P minus 1 mod q equal to 0. Right? So P minus 1 mod Q and 7. P equal to 7 we considered earlier. 7 minus 1 6. 6 mod Q equal to 0. What is the Q value? Q equal to 3. So we can consider Q equal to 3, then 6 mod 3 equal to 0. So the value of Q is 3 and whole mod the prime number P is 7. See here 2 power 7 minus 1 6 by 3 and 2 power 2. 2 power 2 and 4. 2 square. 4 mod 7. 4 mod 7. This value is 4. So therefore G equal to 4. G equal to 4. Then we go for calculating the value of y. See here y equal to g power x mod p. So earlier we calculate the value of g, right? So g value 4 and x value we consider where x value we consider the 5. X value we consider the 5. So g power the 4 power 5 mod 7. 4 power 5 mod 7. So 4 power 5. 4 ja 16 16 4 ja 64 4 ja 4 ja 16 4 6 ja 24 plus 256 into 4 into 4. So 4 6 ja 24 4 5 ja 22 20 plus 22 4 2 ja 8 plus 1028. So this is equal to 1028 mod 7. So 1028 mod 7 simplify. Then what is the value of this? 7 96 into 7 7 6 42 42 plus 500 47. So the x value this is lies between 0 and p. So 0 is less than p is less than x is less than p. So the prime number p is 7 0. So here we consider the x as 5, right? 4 power 5 4 power 5 1024 mod 7. So 1024 mod 7 is 146 into 7. 7 4s are 42. 7 6 are 42. 2 4. 7 4s are 28 plus 4 32. 7 1 is 7 plus 3 1022. So 10 now this is subtract from this 1022 minus 1024 is equal to 2. So 1024 mod 7 equal to 2. So therefore y equal to 2. Now we calculate the value for g, calculate the value of y. Where? The y value is 2. K lies between 0 and q. Let us consider k equal to 2. Okay. So the sign algorithm r equal to the sign algorithm r equal to g power k mod p 4 mod q. So now you substitute the values g. We calculate the value for g 4, k 2, mod the prime number 7, 4 mod q is 3. See here, what is the value for 4 plus 16 mod 7? 16 mod 7, 16 mod 7. So 2 mod 3, 2. So this value is 2. Okay. Therefore, r equal to 2. So this is the value of r. And now we go for calculate the value of s. Similarly, s equal to a inverse of h of m plus x into r 4 mod q. 4 mod q. See, of k inverse 2 power minus 2 into 2 power k power minus 1, 2 power minus 1, hash inverse h of m equal to 3 plus x into r. X we consider earlier 5 into r. We calculate the value 2 mod q equal to 3. Okay. So here one thing you remember, 2 inverse 3 plus 5 into 2, 13. 3 plus 5 into 2, 13 mod 3. If you take any multiplicative inverse, any number multiplied with this number modulo 3, we should get 1. Right? One more time I repeat. If you take any multiplicative inverse, any number multiplied with this number modulo with 3, we should get 1. So here 2 into 13 mod 3. So 2 is 26 mod 3. 26 mod 3. What is the value of 26 mod 3? Here is 2. Now, therefore, s equal to 2. S equal to 2. R equal to 2. We already calculate. Now, the s equal to 2 we calculate. Then, the parameter t equal to action message h of m into s inverse 4 mod q. 4 mod q. So here what is the value of s2? H of m we already considered earlier, 3 into 2 inverse mod q. So now we discuss the multiplicative inverse. Multiply with any number modulo the q value is 3. The modulo 3, then the value is 1. So 1 in 1. So 3 into 2, 6 mod 3. 6 mod 3, the value of t equal to 0. Therefore, t equal to 0. One more parameter, that is u. Here, now you go for calculate the value of u r into s inverse mod q. So r we calculate earlier r equal to 2 and s 2 inverse mod q. So again the q value is 3. The same thing we recollect the edit multiplicative inverse multiply with any number. Modulo 3 the value is 1. So 2 into 2 this value is 1. 2 into 2 4 mod 3. So 4 mod 3. Therefore u equal to 1. Now you calculate u value is this. And one more parameter, that is v equal to g power p into y power q mod p 4 mod q. So g power p, that is the value of g. Earlier we calculate g equal to 4 power p. The value of p is 0 into y. The value of y we calculate earlier 2 u. The value of u is, here we calculate 2 power 1 mod p prime number 7 we have considered, and mod the value of p is 3. So anything power 0 equal to 1, 2 power 1 2. So 1 into 2 mod 7. So the value is 2 mod 3. Again 2 mod 3 the value is 2. Therefore v equal to 2. This is the value. Now we calculate the parameters r and s in sign or signature algorithm and t, u and v in verifying algorithm. So here one thing you observe in digital signature standard algorithm, v equal to r. What is the value of v? 2. So earlier we calculate the value of r 2. So therefore r equal to v. Hence the digital signature algorithm is proved. The DSS algorithm is proved. So this is the digital signature standard algorithm. This is another algorithm of the public key. Thank you.